this video we are going to see how to run an example from a Rust embedded book. So let's go on to the VS Code, and once you follow this document you will be seeing um, the project folder with following examples. This is generated from the cargo generate, I believe. um, so let's try to run the hello world. So hello world is basically no main, no standard, and panic halt. I think panic is for this unwrap, I believe, and cortex-M RT. So this is for defining this entry point, creating a main. Even though there is no main, this is kind of a virtual main, an entry point that we are creating through this crate. And semi-hosting is for debugging. So yeah, let's see how we can build this. So cargo build hello should build this. In order to do this, probably you might need to we can run the hello world command program. This is the hello world program. It's going to print hello world and going to exit from the QEMU. This is the emulator for ARM. So we are basically running this command QEMU system ARM CPU for context M3 machine this, and enable on target native, and kernel is this one. So we are going to create an executable file for ARM processor under this folder. So let's run this, and it's already running and it's printed the hello world. So let's move on to run device example. How we are going to run this? We can run this with this. Here the only thing is we need to change the target to non EAB IHF. What is this, the meaning? Let's see what is the meaning of this. Some they have given the definition, some of the examples. Let's see where it is. QEMU. QEMU system, QEMU emulator tells you to emulate the cortex M3 CPU machine. No graphics, semi-hosting, would agree. What is this build types? this target. Okay, M4 and M7, this is the target. I think M4F and M7F. It's some processor versioning, I think, different processors, architectures. Yep. Moving on to here, so we are going to run device. So basically it's running this program. Oh yeah, since we already built, that's why it's running. If you want to run this program, build this program, how we will build is through cargo build -example device. Let's say this will build. Yeah, it's building. Then you can run the emulator command with this. So it's basically what this program is doing is it's creating a system clock, syst clock. So syst clock is a clock which start counting down. So we have to, if we set 10, it will start counting 9, 8, 10, 9, 8, 7, 6, like that until 0. So our main, we are taking a peripheral from cortex-P and p.syst. Here we are taking the syst clock peripheral, and we are also taking getting a interrupt vector table NVIC, and we are enabling the exit 0 interrupt. So what exit 0 is an interrupt function we are declaring here. It will basically count a static variable and it will start printing it when this interrupt get triggered. When this interrupt is getting triggered, that is what we want to see again. So first we are setting the clock. So this will set the system clock as core, and we are loading, as I said earlier, 10 for starting the counting. Here we are setting 8 million, I believe. So 8 million here means it's actually 1 second. So it start counting from 1 second onwards, and when it become, and we are enabling the counter when so this is the infinite loop, and while loop we are putting syst dot has wrapped. So this while loop will be looping until the timer wraps around. So that means 1 second. When 1 second end, it will come down here and it will call this interrupt, trigger the interrupt. So pend interrupt 0, that's how we are calling the interrupt, triggering the interrupt. So it will trigger this interrupt, and this is where we are printing the ticker. So it's actually basically ticking pretty fast, I think every 1 second. So let's see if we decrease this, what will happen. Probably we can give 1 and see how fast it is ticking. Yeah, it's ticking pretty fast. So let's decrease this countdown a little more down, so it will be much quicker. This is not 1 second. It's not 1 second now. So It's not, we have to build this. Yeah, it's so fast. Yeah, let's make it 1 second again. I think according to the assist clock cycle, basically if we take the frequency calculation, around 8 million is what 1 second, I believe. So let's see. Yep, just 1 second. Yeah, I think that's all I want to cover this. Probably I'll be going through this Rust embedded book, more examples, and we will record this sometime later. Yeah, thank you for watching this video. We will see you later. Thank you.